Alright, now in this we want to look at slopes of straight lines and kind of see what happens with them. And so I'm going to start with just defining some straight line. I'm going to use f of x because I want to operate on it and do some algebra with these to see what happens. And let's go with 3x plus 1. Okay, so there we have it. I have that. And now what I'd like to do is say, okay, what happens to the slope of this thing if I multiply the function by 3? So, no, not 3. I'm already using a 3 for the slope. So let's multiply by 2. So suppose I take 2 times f of x. What's happened to the slope? Okay, well there's 2 times f of x. Well, what I can do is I can actually multiply things through and kind of look, and we see that if I multiply this by 2, I see that I get a 6. And so if I look at 6x, okay, now that's not quite the same curve, but it does appear to have the same slope. These look parallel, right? So parallel slopes, parallel lines will have that same slope. So it does look indeed like what happened was I simply multiplied, by multiplying the function, I multiplied its slope. Okay, so that's a good thing to remember, okay, is that if I multiply a function by a constant, I multiply its slope. Well, so what happens if instead of multiplying by 2, I multiply by half or divide by 2? Okay, what happened then? Well, I'm going to take 3 halves, 3x over 2, or 3 halves x, and again the slopes look parallel. So we see if I'm multiplying by a constant, then it appears that the slope is the same. Now we can check that even better. I'm going to come back here and come down here, get rid of that, and I'm just going to multiply by an a and add that slider. And then here, well, I'm going to do the same thing, same sort of thing, is multiply this by a. And so as I change a, those lines are always parallel. So they're always parallel. Nice. Okay, so we see that what it looks like is I start with a function that has a particular slope. Now this is a straight line, but I start with a function that has a particular slope, and I multiply by by some constant like that, and what happens is the slope just gets multiplied by that constant. It's the same thing. Great. Okay, so we have that. Now let's change this up a bit and say I have another function, g of x, that equals maybe minus 2x plus 5. So there's g of x. I'm going to get rid of that and get rid of that. And so there we have our 2 straight lines. Now what happens if I add those 2 things together? So there I've added them. I get this new thing. It's a blue, so whoops. I don't like that. I'm going to change that to an orange so it looks a little different. Okay, so there's the orange line. And, what the heck is that slope? Well, once again, I know how to do some algebra and so forth. So I think what happened was I just had 3 and then plus a minus 2. So when I added those, so I'm doing that way, I need to put some parentheses around these things and multiply that by x. And again, you see those two lines there appear to be parallel, and they are. And so it looks as though if I add two functions together like this, then the resulting slope is just the sum of their slopes. So the sum of the functions, I get the sum of their slopes. Okay? That will be important soon, you know. And we can see it there, and it's very obvious here with this picture that it appears to work just fine. Great. Now, what if we do minus? Well, I'll just change that to a minus. And once again, green and orange here, you know, turn that one off for now, and that one. And we see that, once again, they're parallel. So if I have these two functions and I find their difference, then I want to know the slope of that difference. Oh, it's just the difference of their slopes. Nice. So multiplying by a constant or adding or subtracting, you get answers that you would love to have. Okay? That if I ask what happened to the slope of my line here, if I add two lines together, I just add their slopes to get the new slope. If I subtract two lines, I just find the difference of their slopes. And if I multiply a line by a constant, I just multiply the slope by that same constant to get the new slope. Great. Nice and easy. Now though, let's look at what happens if I multiply them. Bummer. Okay, I don't even get a straight line. Okay, so all of a sudden it's a little hard to talk about slope. Okay, so multiplying, not so nice. I mean, you know, I'm not talking about a slope here because it's not a straight line. So something funky happens here if I multiply these two functions together. So that didn't work out so well. Bummer. Well, what if I divide them? You know, is that like dividing the slope? So definitely multiplying the two functions is not like multiplying the two slopes, because if I multiply these two slopes, I get -6. That is not a straight line with a slope of -6. Okay, so what about dividing them? You know, if I take f of x divided by g of x, would I get a slope of what, -1.5? Do the division. Oh, well, I'll put my g of x there, and all of a sudden you go, oh, that's a straight line. Well, no, it's not. I've got to get rid of this g of x there. Definitely not a straight line. Oh, and that's, I mean, it's not even a nice function. I've got this vertical asymptote here, right? Well, not a nice function. It's a perfectly fine function, but it doesn't look anything like a straight line. And so dividing them, no, it doesn't work. So again, multiplying by a constant, lovely. Okay, it just changes the slope to whatever I multiplied by times the old slope. Right? If I add two lines together, lovely. I just add the two slopes together, I've got the new slope. Subtract one from the other. Oh, find that difference, find the difference of the slopes, and there I've got the slope. So multiplying by a constant, adding and subtracting, great things to do for slopes. Multiplying or dividing, on the other hand, not great. Okay, weird things happen. And what we want you to do is remember that for a whole extra chapter, because you know we're going to remember that when we get to, or want to look at this when we get to chapter 2. So we've got to go clear through chapter 1. I'm asking you to remember that idea. Will you? I don't know. But we'll talk about it when we get there to chapter 2. But here's an interesting thing with the slopes. Again, you know, multiplying by a constant, great. Adding, subtracting, great. Multiplying and dividing, not so great. Okay, so that's what I wanted to talk about with algebra of functions this type of algebra of functions and slopes.